In this video, we're going to use this formula here, integral of du over u squared minus a squared equal to 1 over 2a natural log of absolute u minus a over u plus a. So we're going to use it to evaluate this integral here. So we want to evaluate the integral of 1 over 16 minus 9x squared. And this is one where the integrand is a rational expression. So the method of partial fractions is going to work. But there's a lot of formulas that you can use. And of course, if your instructor makes these available to you on a test or tells you can use them if you know them, then we're going to show how to use this one here. So you want to have it in this particular form. So notice here we have it in terms of x. Now if this was written as 1 over, and you add x squared, say minus 4, you wouldn't need anything else. You just go right to the formula. But sometimes it makes it easier if you use a u substitution here. So I'm going to let u equal 2. So look at this. Look at the 16 here as the a squared. So this is 4 squared. And look at the 9x squared as 3x squared. So we let u equal to 3x and a equal to 4. We have in that form. So let's let du equal to 3x. Then du equals to the derivative of 3x, which is 3. And then this would be dx. Divide through by 3. Then du over 3 would equal to your dx. Now let's try to write this in that particular form right there. So notice it has the u squared first here. So this is u. So this would be the integral. I'm going to factor out a negative out of that. So I got a minus here. So this would be then the dx would be in the numerator times 1, still dx. And the dx is going to be du over 3. So I'm going to factor out the 1/3 out in front. And then I've got du. And because I factored out a negative, say from the denominator, this changes signs here. So this would be a u squared. This is u here. 3x is u. So this would be u squared minus, and this would be 4 squared over here. This is 16. Now it's in this form here. U squared minus, and then the 4 squared, that'd be a squared there. So then we can just go directly to the formula then. So it's going to be, coefficient of this then will be 1 over 2a. But what is a? A is 4. So it'd be times this coefficient then, which is 1/8 there. But it's going to be, that's going to be in the final answer though. So the way I would write this then, so to go into the answer now. So this would be multiplied then by 1/8, so it'd be a negative 1 over 24. So that would be this part right here on the answer part. 1 over 2 times a, and a is 4, so this would be 1/8. But remember we have the 1/3 in front, negative 1/3, so it makes it a minus 1 over 24. That's negative 1 over 24, and then it's be the natural log of the absolute value of u minus a. But in our case, u is 3x, so we've got to go back to the original variable anyway, so let's just do it here. It'll be 3x minus a, and a is 4, so it'll be a minus 4 here. And that's over u, which is 3x, plus a is 4. And it's plus the constant of integration. So there you have it, minus 1 over 24 times the natural log of absolute 3x minus 4 over 3x plus 4. So this is your answer right here. But always keep in mind when you're working problems like this, integration problems, just like there's more than one way to solve or evaluate the integral, there's more than one way to give the answer in some cases. If you simplify, use algebra, properties of logs. So for example, this can also be written as, this is a negative 1 over 24. I could take the negative 1 over 124 up as an exponent, or I could just take the negative there and leave the 1 over 24 here. So let's just take the negative up here. That's the property of logs. And I got the natural log here. So if we can get to a negative power here from this value right here, negative 1 here, it just reciprocates this. It gives you the reciprocal then. So this would be just absolute value of 3x plus 4. It's going to be over 3x minus 4, plus the constant of integration. And that's 2 ways to write the answer. The first one's correct, this one's correct. So here we were told to use this formula here to evaluate the integral. But you can also use partial fractions. So I'm just gonna, this is the end of the video, so if you don't want to watch from here on, that's fine. But I'm just gonna show you or set it up using partial fractions. So here's the setup. Factors into 4 plus 3x and 4 minus 3x. So they're both linear. So I have a constant over the first factor, another constant over the second factor. And again, it doesn't really matter what order you put these in the denominator. The 4 minus 3x could go first, and then the 4 plus 3x. There it is. Then we clear the fractions, and we get the second equation. 1 equals to a 4 minus 3x plus b 4 plus 3x. Multiplying both sides by the LCD. And then we collect the x terms, and then factor out the x. So we have minus 3ax plus 3bx. Collect the terms there, factor out the x, and then the 4a plus 4b, that represents a constant. You have to treat this as an identity. So on the left side, we don't have an x. So that means the coefficient of the x is 0. So that tells me that this product, or this expression here, has to equal to 0 because there's no x over here. So it means the coefficient has to be 0. And then this doesn't have an x, so this is considered to be a constant. What's the constant on the left side? 1. So that tells me that 4a plus 4b has to be 1, and minus 3a plus 3b has to be 0. And then it's just a simple solution using elimination. You can use any method you want, but you can solve it easily by elimination. You get a equal to 1/8 and b is equal to 1/8. So then the integral 1 over 16 minus x squared dx would equal to, so then right here, a is 1/8, so it'd be 1/8 over 4 plus 3x. So a is 1/8, so I have it up here. It's plus, the b is also 1/8, so this will be 1/8 over 4x minus 3. I should say 4 minus 3x. And then this is going to be the integral dx. So we have two integrals. You can use your u substitution here. So using u substitution here, u equal to 4 plus 3x, then du would be 3x divided by 1/3. I'm going to get a 1/8 times 1/3 is 1 over 24. And this would actually turn out to be du over u. That has a integral of ln of absolute 4 plus 3x. And then this was the same thing, except this one I have a 4 minus 3x. So when I let u equal to 4 minus 3x, I get a du equal to a minus 3 dx. Solve for dx. Here I get a negative. I'm still going to have the 1/3 times the 1/8, so this would be minus 1 over 24. And then this becomes a du over u. And then that is just the ln of absolute 4 minus 3x. And this is x here. This will be 3x here. You have your constant of integration. Now again, this looks different than what I got using the other formula, but remember, there's properties of logs you can use. So I'm going to go back up here. You can factor out the 1 over 24. So factor that out. Then you have the difference of two logs here. So that means I can write this as 1 log. And it's going to be the absolute value of this value, this expression over this expression. So it'll be 4 plus 3x over 4 minus 3x. And that's the second answer that I gave in the previous formula when you use the initial formula. And then your constant of integration. So you can use it. You can solve this one by partial fraction decomposition. Thanks for watching, and we'll see you next time.